Okay, good evening. We are here for electrical principles, and our subtopic for the day is we are looking at serial parallel connection, and our learning outcome is by the end of the session we should be able to perform calculations involving serial parallel connection. But don't forget to like, subscribe, and share. So let's look at our first example. Our example number one, we have this as an example of a circuit whereby it has components connected in both serials and both parallel connection. So we have serials and parallel connection. And our example says that given that R1 is equals to 2 ohms, R2 is equals to 4 ohms, R3 is equals to 10 ohms, R4 is equals to 47 ohms. If the supply voltage is 230 volts, calculate the following: the total resistance, the total current flowing through the circuit, the voltage drop at R1 and R2, the current flowing through R3 and R4. If you look at our circuit here, we can see that R1 and R2 are connected in series, while R3 and R4 are connected in parallel. And there are some notes that we know about serials connection and parallel connection. So when talk about serials connection, there are very important points that we know: that current flowing through components in a serial circuit is assumed to be the same, whereas the voltage is assumed to be different. But in parallel connection, we know that voltage drop across each component is assumed to be the same, whereas current is assumed to be different. Now let's look at the solution. Let's try to solve our problem. So our first question asks us to calculate the total resistance. And as we have said earlier, or as we have seen earlier, is that R1 and R2 are connected in series, while R3 and R4 are connected in parallel. So step number one that we're supposed to look at is to look for the total resistance of the two resistors that are connected in parallel, that is R3 and R4. And we know that in parallel connection, when you are calculating the total resistance, it is given by the product of the two resistance divided by the sum of the two resistance. Our two resistors is R3 is 10 ohms and R4 is 47 ohms. So we shall have 10 multiplied by 47 divided by 10 added by 47. So we shall have 470 divided by 57. And when you take your calculator, you key in 470 divided by 57, you shall get 8.2456 ohms. That is our total resistance in that section. And remember to write your answer into 4 decimal places. So after calculating the total resistance for the total resistors connected in parallel, we shall now draw our equivalent circuit. So we shall have our two resistance, that is R1 and R2 connected in series, plus our equivalent resistor, for us to get the equivalent circuit for this. So when you check at this diagram here, we can see that R1 and R2 and R3 are connected in series, and therefore that makes our work easier for us to calculate the total resistance for problem 1. And we know that in a series circuit, the total resistance is given by R1 plus R2 plus R3 plus R4 all the way to Rn. In our case, we have three resistance. That is, so we shall have R1 plus R2 plus our R equivalent. That is 2 plus 4 plus 8.2456 ohms. And our total resistance for our problem number one, we shall say it's 14.2456 ohms. That is our total resistance. And I believe you have understood in that section. Let's look at our problem number two. Total current flowing through the circuit. How do we calculate current flowing through a circuit? Using Ohm's law, we know that voltage is given by current multiplied by resistance, and voltage is abbreviated as capital V, current is abbreviated as capital I, and resistance is abbreviated as capital R. Therefore, V will be given by I multiplied by R. But in our case, we are looking for I, sorry. So let's make I the subject of the formula. So you divide by R, you divide by R. R and R will cross. We shall remain with I is given by V over R. And from our previous slide, we have seen that the supply voltage is 230 volts. That is our V. And our total resistance is 14.2456. Therefore, our I will be given by 230 divided by 14.2456. And we shall get our total current flowing through that circuit as 16.1453 amperes. Kindly remember to always write your answer corresponding to the SI unit of the component or the equation as the question asks. If it's voltage, remember to write volts. If it's resistant, remember to write ohms. If it's current, remember to write your answer in amperes, because we know that current is measured in amperes using our instrument, that is ammeter. We had seen that in our previous slide, but don't worry, we can as well you can as well visit our previous videos. They are as well uploaded in our YouTube channel. So let's look at problem number three. Problem number three asks us to look for the voltage drop across R1 and R3. Let's go back to our circuit. This is our circuit. We know that the supply voltage from here is 230 volts. As the voltage moves to this end here, we shall have a voltage drop. And as well it is moved to this other side, we have a resistance here and we have a resistance here. This resistance is opposing the flow of the current. Therefore, we shall have a voltage drop here and another voltage drop here. Why? We know that in a series circuit, current is assumed to be the same, flowing to each and every component, but the voltage is assumed to be different, and therefore we shall have a voltage drop here V1 and another voltage drop here known as V2. But in this section we can say that these two resistors are connected in parallel, and therefore our voltage here will be assumed to be the same. So let's look at V1 and V2. How do we calculate V1 and V2? So R1 and R2 are connected in series, and therefore current is assumed to be the same, but voltage is assumed to be different. We had seen that. So V1 will be given by I, which is assumed to be constant, multiplied by R1. Our I is our total current. We have calculated it in the previous slide. So our total current was 16.1453 and our R1 is 2 ohms. Therefore, the product of these two will give us the V1, the voltage drop across V1. And therefore, our voltage drop across V1 will be 32.2906 volts. Is that clear? Then V2 will also be given by I, where I is constant, multiplied by R2, and our R2 is 4. Therefore, our V2 will be given by 16.1453 multiplied by 4. And if you take your calculator and key in, we shall get 64.5812 volts. Always remember to write your answer into 4 decimal places and don't forget the SI unit. I believe that is clear. Let's look at the problem number 4. We are being asked to calculate the current flowing through R3 and R4. Let's go back to our circuit. Current flowing through this R4 and this R3. We can see clearly that R3 and R4 are connected in parallel. And from our NB, we know that our current flowing through resistors connected in parallel is assumed to be different for each and every component, but the voltage is assumed to be the same. Let's go back. So, our supply voltage, which is 230, minus the voltage drop across R1 and R2, will give us the voltage drop of voltage flowing through R3 and R4. Is that clear? So V3 and V4 will be the same since they are connected in parallel. Therefore, we shall get 230 minus our V1 plus V2. And that is that we are getting 133.1282 volts. That is our voltage drop at R3 and R4. Therefore, I3 will be equal to 133.1282 divided by 10. That will give us 13.3128 amperes, and our I4 will be equal to V divided by V4 divided by R4, sorry. That is 133.1282 divided by 47, and therefore we shall get 2.8325 amperes. I believe you have understood that, and I believe it's clear. But if any question raised or concern, you can raise it in the comment section. So I have an assignment for you here. You can as well try it, and if any challenge arises, kindly also raise your concern in the comment section. Assignment says that given that R1, R2, and R1, R2 are connected in series, and R3 and R3, R4 are connected in series also, but in parallel with R5 and R6. Calculate the following: the total resistance, the total current flowing through the circuit, the voltage drop at R1 and R2, and the current flowing through R3, R4, R5, and R6. This one is just, if you have understood our example number 1, I believe it will be clear for you to also do that exercise. May God bless you. Remember to like, subscribe, and share. Thank you so much. That is our end of our session.